For this lesson, 2.5.8, you will be classifying lines as either parallel, perpendicular, or neither. So our objectives are to determine if lines are parallel, perpendicular, or neither, and we'll look at it both algebraically and graphically. In our first problem, it says, are the graphs of 4y equals negative 5x plus 12 and y equals 4/5 x minus 8, are those parallel, perpendicular, or neither? So here are the steps to figuring that out. Step 1. Find the slope of each line by writing it in slope-intercept form. And if you remember what slope-intercept form is, it is y equals mx plus b. Okay, so it looks like this. Y equals mx plus b. So the question is, why write it in slope-intercept form? And here is the reason. You can easily identify the slope, which is m, of an equation in slope-intercept form. All you have to do is look at this m, this coefficient of x, and that will tell you what the slope is. And remember that we said earlier that the slopes of lines that are parallel are the same. So let's do that. Let's look at our two equations. Well, line 2 is already written in slope-intercept form, so all we have to do is adjust line 1. Line 1 is the only one not written in slope-intercept form. Okay, so in order to do this, we will go ahead and write it out. So we've got 4y equals negative 5x plus 12. It's very close to being in this form, except that we have a 4 in front of the y. In order to get rid of the 4, we would need to divide every term by 4. And now let's simplify. 4 divided by 4 is just 1, or 1y, and that equals negative 5 over 4x. That is our slope. And plus 3. 12 divided by 4 is 3. Okay, so we have y equals negative 5/4 x plus 3. Let's copy that so we know what that is. We have that. And let's go to the next page and look at step 2. So step 2, here's our slope for line 1, written in slope-intercept form. Our slope is negative 5 over 4. So since the slopes are not the same, line 1, it's negative 5/4, and I'll go ahead and highlight that. That's what we just calculated, right? But in line 2, the slope is 4/5. So since these slopes are not the same, the lines cannot be parallel, but they may be perpendicular. And if you remember, one of our tests to determine if slopes are perpendicular is to see if they're opposite reciprocals. So we can look at our slope here and say, well, this is negative, so this has to be positive, which it is. The reciprocal of 5 over 4 is in fact 4 over 5. And we had one other test too, if you remember. If we go ahead and take these two slopes and multiply them, so we take negative 5 over 4 and we multiply that by 4 over 5, do you remember what we should be getting? This will probably help you remember. Let's try it. So negative 5 times 4 is negative 20, and 4 times 5 is 20. Negative 20 divided by 20 is negative 1. And remember that lines are perpendicular if their slopes, when you multiply them, equal negative 1. So these slopes are both perpendicular to each other. The lines, I should say, are perpendicular to each other. All right, let's look at another problem algebraically. In problem 2, we are wanting to know if the graphs of 4x minus 3y equals 9 and y equals 4/3 x plus 7 are parallel, perpendicular, or neither. Let's start with step 1. Find the slope of each line by rewriting it in slope-intercept form if necessary. Well, line 2 is already in slope-intercept form, so we will only need to rewrite line 1 in slope-intercept form. Okay, so what we have is 4x minus 3y equals 9. We have a little more to do here. We need to move everything to the other side. So let's move the 4x over. Let's subtract 4x from both sides. Okay, and what I'm left with, 4x minus 4x is 0, so that's gone. And then I left with negative 3y on this side. And on the right side, I have a minus 4x, and I'm going to go ahead and write that first. And then I still have my plus 9. I'm going to write that second, just to get it closer to slope-intercept form. Finally, my last step, I need to move the negative 3 over. I need to solve for y, so I'm going to divide every term by negative 3. Negative 3 divided by negative 3 is just 1, or 1y. Negative 4 divided by a negative 3 gives me just a positive 4 over 3. And 9 divided by negative 3 gives me negative 3. Okay, so here's our equation that we get from slope-intercept form. Let's go ahead and move that over and think about our step 2, what we need to do. Okay, so in step 2, we just need to compare our slopes. Okay, our slope in our second equation was 3/4, and our slope in our first equation is 4/3. So are those parallel, perpendicular, or neither? Well, they're definitely not parallel because they are not the same slopes. Are they perpendicular? Well, a quick, easy way to check is, first of all, they need to be opposite signs, and they are not. They are both positive. They are reciprocals, but they are both positive. So if we were to multiply those together, we would get a positive 1 and not a negative 1. So in this case, these lines are neither parallel nor perpendicular. Okay, now let's look at our third problem. Now we are looking at these lines graphically, and they certainly look parallel and perpendicular, but we need to prove it. So in each of these graphs, are these lines parallel, perpendicular, or neither? So if we take the first graph, we need to figure out the slope of each of these lines. Well, if you have a graphical line, it's easy to do. You just pick 2 points. So perhaps I'll pick a point here and here, and I'll figure out my slope. So to get between those points, I'm going to go up 1, 2, 3, and over 1, 2, 3. 3 over 3. So my slope for the blue line is equal to 3 over 3. And you may be thinking in your head right now, well, I can reduce that, and I can reduce that to 1. Okay, now let's go ahead and look at the green line. So same thing, I'm going to go ahead and pick 2 points, and maybe I'll pick this point here because it's right on the crosshair, and so is this point. And I can go over 1, 2, and up 1, 2. So 2, 2. So for the the green line, my rise was 2, and my run was also 2, and I can simplify that to be 1. So in this case, I can see that my lines are in fact parallel because they have exactly the same slope. Okay, so I only need to count when I see it graphically. Let's do the same thing for the graph below. Now I could take these points and I could calculate the slope by doing y2 minus y1 over x2 minus x1. I could definitely do that. Or I can just count like I did before and then determine if my slopes are opposite reciprocals of each other. So I'll go ahead and choose the points that are circled because that would be really easy. So if I do that, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So I'm going up 8 in this case. And I'm going to go over 1 to here, 2, 3, 4, 5, 6, 7, 8. So in that case, I'm also going to go over 8. Oops. So my slope for my red graph is 8 over 8, which reduces to 1. Now let's go ahead and look at the purplish blue one. And we can choose the same 2 points that are circled if I want, or I can choose different points. And one thing we need to notice that I didn't point out to you guys is that this red line is negative sloping, right? And that's the danger of counting, because you just count 8 over 8 and you don't think about the slope. If I were to have chosen the points and calculated the slope, I would have come up with a negative 1. Okay, because in reality, going from left to right, this graph has a negative sloping line. So my slope there is negative. If I'm going to look at this bluish graph, I'm going to go ahead and choose a different point rather than these two that are very spread out. So here's another point, actually right next to it on the crosshairs. This makes it very easy. All I have to do is go up 1 and over 1. And so for my blue line, my slope is up 1 over 1, which is equal to positive 1. And notice these are opposite reciprocals of each other, right? The signs are opposite, and 1 is like being over 1. If you flip it upside down, you still get 1 over 1. Okay, and that concludes our lesson on identifying whether lines are parallel, perpendicular, or neither. So hopefully when you try the practice, you will be able to look at equations algebraically as well as graphically and determine if lines are parallel, and if they are, their slopes will be the same. If lines are perpendicular, remember their slopes would be opposite reciprocals of each other. Also, if you multiply the slopes, you should get negative 1. Or if neither of these work, then your two lines are neither parallel or perpendicular.